So before I show you how to build this motor, I need to explain to you how it works. And I'm sorry, this is boring, and please don't skip through it because it's very important for you to understand how this motor works. Okay, first things first, let's talk magnets. Magnets are interesting. Magnets have two sides to them. They have north and south. Why they're called north and south, I will tell you. North always points north, whether that represents correctly because it's probably pointing up instead of north. Just bear with me, okay? So, north always points north on a compass. South always points south on a compass. So, north of the magnet always points up to the north side of Earth. And this is because of Earth's magnetic fields. You've probably heard of that. I'm not going to get into depth with that. Okay, back to the curious thing about magnets. Well, if you put two sides together and they're the same, north and north or south, then they hate each other. They repel. But if you get south and north, south and north, and you put them together, they are very attracted to each other. They're the best of the buddies, so they're always trying to hug. Okay, now let's go to the material. Why specifically enamel-coated wire? Well, enamel is very thin, and we need it to be thin because we want the wire to retain its normal thickness. And the special thing about enamel is it doesn't it's not a conductor, so it blocks energy from traveling through the metal. And when there is a blocker, energy just doesn't travel as it normally does. And what happens is you need to scrape off half of the enamel on half the side of the end of each end of the wire. So the shaded part would be the enamel coat, and you scrape off with a knife this part, half of it, exactly half of it, on each of the ends. Make sure they're facing the same way. Now, this is important because of a later step. I'll explain to you. And I will show you how this matters. Okay, so there's this coil here, also another part. There has to be a magnet and two wire posts that are connected. Oh, and these have to be non-coated with enamel. Like, you cannot have them coated with enamel. And they have to be in contact of positive and negative side of a battery. Okay, this is the battery. So this side is attracted to this magnet, and this side does not like the magnet, so it wants to run away from it as fast as it can. And this side is attracted, so it wants to go to the magnet. And that's all good. And I'm going to erase this and show you what happens. Actually, I'm going to show you. So this part will go spinning to here if you nudge it, like at the start, and it will go to the magnet. Now, when the wire gets what it wants, it's close to the magnet. The side that's attracted is close to the magnet. It's attracted to each other. So these two are bonding. They love each other. Okay, now here's the thing. If you don't get something to change, it's going to stay this way.
Momentum is a solution, but only for once or twice, because every time the motor spins, there's going to be energy that is lost, and at some point there won't be enough energy to keep it going.
So, back to the enamel-coated wire. It's important because now the enamel coat is not in contact with the two conductive metal posts, and the conductive side of the wire is connected to the conductive posts. So now what happens is energy can flow through this into here, and that energy can make this change. So say this was north, and energy flows. Oh, now it's south, and this is north. Okay. Fun fact, I need to show you something. It's quite fun. It's a really good thing. It was discovered some time ago. I'm sorry, I don't remember the exact name and date of the person who found this and what time it was founded, but sure, I can tell you this. So, say this is a coil. Say this is a coil, and you have electrical energy flowing around it in this direction. Then what you would do is you would wrap your finger. Always use your right. No matter, like always, when you do this, you have to use your right hand. And apologies, that's not a B, that's a R. Okay, so you wrap your fingers around the pencil in the direction of the electrical flow. And stick your thumb up like you're making the thumbs up sign. I know, my hand is terrible. Don't judge. Okay, so you have your thumb up, and this is your thumb. The direction of your thumb, like if it's pointing up, then this side is north. Now, if you flip it, but if you flip it around and your thumb is facing, this side, like you're doing your thumbs down, this side will be north. Okay? Got it? Okay, back to how it works. So essentially, what happens is when the side, so this is the thing, and there's two hoops, and there's the battery and the magnet. So essentially, it will spin because of the energy and magnets. So next time your parent asks you, whoa, how does this motor work that this video shows? Then you can explain to them how.